Okay, and I'll add one more thing to this picture before we proceed and actually apply the cosine law. We're going to apply, or pardon me, denote that angle theta between the two vectors x and y, which theoretically at this stage in principle, this theta plays a role in calculating this dot product, but we're going to show now that we don't need it. So let's apply the cosine law to this triangle. See how these triangles kind of match up? Right, we've got a triangle there, and we've got a triangle there. We're just going to match this triangle to this triangle and then see what the cosine law tells us. So the cosine law tells us the following. Let's first start the sentence. Well, let's just do it symbol for symbol. So start at the left-hand side of this equation. We've got c squared. So in other words, that's the square of this side, right? C squared. What's that down here? That's this side, which is the distance between x and y. Or really, it's just this. It's the norm of x minus y. But we got to square it, right? Because there's a square in the cosine law. So the left-hand side of the equation, if we copy this, but for this triangle, we're going to get the norm of x minus y. Oop, off the screen. We're going to get the norm of x minus y all squared. That'll be the first thing on the left-hand side of our equation. So what's next? Now, on the right-hand side, we're going to have a squared plus b squared. So that's the sum of the squares of these two sides. Well, what is that over here? Well, a squared, forget about the a squared for now. A is this length, right? And b is this length. So this length is actually going to be the norm of x. The norm of x is going to tell us how far apart these points are, and then the norm of y is going to tell us how far apart these points are. So if we're applying the cosine law here, we're going to have the norm of x squared plus the norm of y squared. So that's what we're going to have on the right-hand side for those first two terms at least. So this is going to be equal to the norm of x squared plus the norm of y squared. Okay, so that's the first two terms. But now we still have this minus 2ab. Remember, a was the norm of x and b is the norm of y. So we still have, let's just keep going with that, minus 2 times the norm of x times the norm of y. And then the last bit of that final term, cosine of capital C. Capital C is down here. So down on our triangle, that's this angle here, theta. So that's why the cosine law ended up being exactly what we need, because now we just need to multiply by cos of theta. So this term here, just to recap, is really just this term here, but in the specific case of this triangle. So that's what the cosine law tells us. Okay, and really from here, what's going to happen is we're just going to clean this up. We're going to write out what all these three things mean. We're going to expand everything out, and once the smoke clears, it's all just going to evaporate. All the needless stuff is going to evaporate, and we're going to end up with this. That's what I'm claiming to you. So let's check that that's the case. Let's work out these three things in terms of the coordinates, because you can do that. So the norm of x minus y, let's just look at that in detail. We've already got it written down up here. Let's just carry on with what it would be. Right? Remember the formula? The length of x minus y is just given by this formula in general. This is for Rn, but we're in R2. So we're just going to chop that off. We're just going to use this. This is really going to be the norm of x minus y here. So that's where that's coming from. We're going to get the square root of x1 minus y1 all squared plus x2 minus y2 all squared. Okay, that's how we can work this out. We've got it over here, and then down here we need the norm of x. Let's just write that out. So the norm of x. Remember, by definition, that's just going to be the square root of the sum of the squares of these two coordinates. So you're going to get x1 squared plus x2 squared. That's going to be the norm of x. And then we also need the norm of y. Same idea, but let's write it out as well. So the norm of y is going to be the sum of the squares of these two coordinates. So we'll have the sum, or the square of y1 squared plus y2 squared, right? So that is, those are our norm of x and norm of y. We'll plug those into these two parts here. And then this one, we have worked it out up here. So we're going to plug these three quantities in for these three quantities. Now these over here, what's this? That looks familiar. That's nothing out of the ordinary. That's not, or nothing that we can't deal with, because that's exactly this, right? So it's just the dot product of x and y. So let's make that observation now before we start the next page. This is just the dot product of x and y. So really the dot product of two vectors is kind of built into the cosine law, right? It just kind of shows up here. This is really a dot product if you set up the vectors properly. So let's do that. Let's plug these three quantities in for these three quantities, and then replace this with the dot product of x and y and see what we get.